assembly-level code. We of course have introduced more code that will be less efficient and will probably have a larger memory footprint. So the next step, of course, is to eliminate the clock, the C file for the clock, and have actually implemented all the functions for the clock in C++ level. And in this extremely simple way of having a simple clock, it was actually smaller and faster using C++ than using C. Most of the reason is because C++ inlining is much better than C's inline functions. So reuse your C code and maybe in a later time implement it as C++ code. As a C programmer, you really like to know, you like the fact that everything I do in my source code is traceable in your assembly level code. However, C++ is very nice. It can introduce code that you haven't written, and in some cases you're not aware of. And as a C programmer, it makes you a bit uneasy. For instance, it creates temporary objects. We have one class here called Fibonacci, and a function that returns a Fibonacci object. Sorry. When we have this code, we create a Fibonacci object and we assign it to 1. It seems a bit illogical. We have an object of type Fibonacci and we assign it an integer. However, C++ is very clever. It realized that we have a constructor that takes an integer. So what actually will happen is that it will call the constructor function and create a Fibonacci object with that one as input to the constructor, which means that that constructor will construct a temporary object, which then will be assigned to the fib object. And in the same vein, if we call some function and take the return value, we will actually first create the local fib object in some function. We will actually copy that to return a temporary return value object, and then we will return that object to the function, and we will do an object copy assignment when we get back to the code. In some cases, the compiler can eliminate these extra copies, but in most cases there will still be a bit of a trace of them. Yeah, this is actually what will happen. We will create an object which will have a copy constructor for that function. So to minimize the effects, we earlier, when most C programmers in the embedded industry learned about C++, we have the rule of 3. If we have a complex object, you should have a destructor, a copy constructor, and a copy assignment operator to ensure that you do these temporary copies as efficiently as possible. However, with the later C++ standards, starting with 2011, we get the rule of 5, where we now have a move constructor and a move assignment operator. These functions, constructor and assignment operator, are aware that the incoming objects are temporary objects. So when you get the call to a move constructor or a move assignment operator, you know that when this function ends, the temporary object will be destroyed, which means that you can do several optimization. Basically, copy semantics with C++03 look like this. You copy the entire object, and then you destroy the original object. And if you have a secondary object, in this case the red one, that's pretty large. You have a large vector, you have a big structure with whatever you need to collect. The copy can be a really big execution time waste and space waste. With Move Semantics, you only copy the base object. You redirect the reference or pointer to the secondary object that we already have. Remove the old reference and we destroy only the old base object. So if this is a very large object, you will save lots of time and lots of space as well. So while you will still get some temporary objects, handling them with current C++ implementations is much cheaper than they were earlier. So, conscious choices. We have 5 different goals with our project, so in times we have to make choices between them. And I'm going to go through some of the features in C++ that you may or may not want to use in your project, but you'd have to make a choice. Exceptions is very useful design if you want to program a robust application. However, they will come with a great cost. You will say every function that's involved in an exception chain will need to add data to add knowledge about that exception chain. And when you actually execute an exception, that will also have to execute code for each called function that's in the chain. So you will get potentially lots of execution speed loss, you will get data loss, but you will get a very useful feature for that price. Templates, C++ way of handling generic functions or generic classes where you can initialize objects with different types. Very useful feature. In this case, we will have a trade-off between ease of use, which it might be, and a very hard to maintain code. Because if you have even more than just the simplest templates, code can be very hard to maintain after a while. But they are very useful, specifically if you're would like to use generic programming. Runtime type information, basically the same trade-off as exceptions. Very useful to have where you can, in runtime, realize exactly what kind of an object you are working with. However, that means that every object needs to store information about what kind of object it actually is. The standard library in C++ is way more powerful and way more useful than the standard library in C. Particularly the standard template library, which is a set of containers like vectors, maps, lists, double linked lists, and so on, and associated algorithms to handle these. You can most likely create better, more efficient containers yourself that are particularly specified to your problem. However, those functions will be less tested because these are available and tested by basically any other user, and you will get a lot faster implementation if you use already made library functions instead of creating your containers yourself. So you have a trade-off between faster time to market and better tested code, and efficiency and code size. So in summary, if you're going to start a new project, preferably in C++, keep a good structure, reuse your C code, maybe later move it to re-implement it in C++, make conscious choices on what parts of C++ you would like to use, and beware of implicit copying and use Move Semantics. So, if you want to learn more, you can go to Marie and get your badge scanned, so then you will get this presentation and all our other presentations emailed to you. And you can visit our demo space at the other end of the booth and see demonstrations of all our new features. And also, if you just want to hang around at 6 o'clock, we have a booth party here, so you can have some beers with us and drink some wine and eat some snacks and so on, and just talk with us. And you can rest your feet in our cozy chairs as well. Thank you.